Well, welcome back. This is Mr. Sire, and this is the second half of our Quarter 3 exam practice for Algebra 2. We're starting with problem 14. We have a complex fraction here, which we have to simplify. So the way to do that is to look for a common denominator. We notice here that the denominators are 2 and 2x. So our common denominator is going to be 2x. So following standard procedure, we're going to multiply both the numerator and the denominator by 2x. So we're going to distribute the 2x across the numerator. We're going to get 18x over 2 plus 6x over 2x. We're going to distribute the 2x over the denominator, and that's going to give us 18x squared over 2 minus 2x over 2x. Now we're going to reduce each of these four component fractions. So 18x over 2 becomes 9x, 6x over 2x becomes 3, 18x squared over 2 becomes 9x squared, 2x over 2x becomes 1. Okay, now all we have to do is factor both the numerator and the denominator. So in the numerator we can take out a common factor of 3, and that gives us 3 times 3x plus 1. The denominator, we notice, is a difference of two squares, so that factors as 3x plus 1 times 3x minus 1. Then we can cancel both the top and bottom factors of 3x plus 1, and we get 3 over 3x minus 1, which is our final answer. Okay, let's go to number 15. Here we're being told that the sine of an angle is negative, and the cosine of the same angle is also negative. So we want to know what quadrant is our angle. Best thing to do here is to draw a chart. We have the quadrants 1, 2, 3, 4. We notice in quadrant 3, that's the one we want, because in quadrant 3 both the sine and the cosine are negative. So that's our answer, quadrant 3. In problem 16, we're given the discriminant of a quadratic equation is 8. Okay, we have this chart that you should commit to memory. We notice that since 8 is not a perfect square, the roots are real, irrational, and unequal. Okay, so real, irrational, and unequal. Problem 17 asks us to solve a quadratic equation using the quadratic formula, which we know is minus b plus or minus the square root of b squared minus 4ac, all of that over 2a. So we go ahead now and identify the a, b, and c in our problem. A is 1, b is negative 4, c is also negative 1. So we substitute into the formula. We do the arithmetic. So we get 4 plus or minus the square root of 20 over 2. We break the 20 up into factors of 4 times 5 because 4 is a perfect square. That 4, the square root of 4, comes out as a 2, which we can now reduce this fraction. 2 into 4 is 2. 2 into 2 radical 5 is just the radical 5. And that leaves us our final answer of 2 plus or minus the square root of 5. Moving on to 18. Here we're given two functions, an f of x and a g of x. And we're asked to write the composition of f and g as a polynomial in simplest form. Okay, so what we're going to do is we're going to take the g of x and substitute it in for the x in f of x. So instead of x in f of x, we're going to have g of x. So it's 2 times g of x squared plus 1. Since we know that g of x is 4x plus 3, we're going to square that. Okay, so now we just need to do a little bit of algebra. Squaring means multiplying by itself. So now we're going to distribute 4x plus 3 across 4x plus 3. We're going to get 16x squared plus 12x plus 12x plus 9. And then we're going to combine like terms. So we're going to get 16x squared plus 24x plus 9. Then we're going to multiply through by 2. We'll get 32x squared plus 48x plus 18, and finally the 1. We combine all of that and we get our finished answer, 32x squared plus 48x plus 19. Excellent. Okay, let's go on to number 19. 19 is a trig problem. We're given a right triangle. We're told that the right angle is at C. We're told that angle B is 50 degrees. We're told that side BC is 5 units, and we're asked for the length of AC. So the way this sets up, we identify the hypotenuse, the opposite, and the adjacent sides. We notice that in this problem, the opposite and the adjacent are the two sides that are involved. So that's a tangent. So we're going to go ahead and set up tan of 50 is equal to x over 5. That means that x is 5 times the tangent of 50, which is approximately 5.96 centimeters. Problem 20 is also a trig problem. So again, we're going to draw and label a diagram. Here this time we're looking for the angle S, so we'll make that an x. We're told that the adjacent side is 5 and the hypotenuse is 13. That looks like a cosine situation. However, in this case, we don't have the value for the angle. That's what we're looking for. So we're going to use the second cosine. So x is going to equal second cosine 5 over 13, which is just 67.4 degrees. Okay, next problem is 21. Now we are asked to write the solution set to an absolute value inequality. We notice that this is a greater than absolute value inequality. The setup for that is to split it into two separate inequalities. One where we are the quantity inside is less than -9. The other one is where the quantity inside is greater than 9. The reason for this is because the absolute value hides the sign. So if this were something like -10, the absolute value would be +10, and that would be, of course, greater than 9. So that's why we need this piece, okay, in addition to the regular positive version. Okay, so now we just go ahead and solve these two inequalities separately by adding 7 to both sides, dividing by 2, and we get on the one side x is less than -1, or on the other side x is greater than 8. Okay, next problem. Okay, so next problem is another absolute value problem. This time we're really being asked to understand what absolute value means. Here we're told it's something about a cereal bar is supposed to have ideally 200 calories. However, when they test the sample, we notice that there's a variation, a change of up to about 28 calories. So we're being asked to write and solve an absolute value inequality. And we're told to let x represent the number of calories in an actual sample. Okay, so what we're saying is that the difference between a particular bar of cereal and the ideal of 200, the difference between those two is less than or equal to 28. So this is a less than inequality. We know how that sets up. So we put the quantity inside in between the negative of 28 and the positive of 28. Then we go ahead and solve by adding 200 all the way across, and we get our final answer of x is between 172 and 228. Okay, next problem. 23 is a problem about exponential growth. We are given the formula P of t equals 62,700 e to the RT. We're given a annual growth rate of 3.25%, and we're being asked first to find the population to the nearest 100 7 years from now. The thing to remember is that 3.25% comes over as 0.0325 decimal. So we plug that into our formula, plug that into our calculator, and the answer comes out to 78,700. Now in part B, we're being asked to determine how many years to the nearest tenth it will take for the original population to reach 100,000. Okay, so we want 100,000. We have 62,700. So we're going to go now and divide both sides by 62,700. We get 1.59 and so on. Now we have the variable up in the exponent position, so we want to get it down. We're going to use the log, kind of like a ladder. Okay, because now since we have e in this problem, we're going to take ln of both sides. So we get ln, ln. We're going to now use the power property of logs to bring our exponent out front. We notice that ln of e is just 1, so that goes away. And now we divide both sides by 0.0325, and t comes out as 14.4 years. Okay, next problem. 24. We're going to solve for the log. And we're given log plus log. So we know from the power property of logs that the sum of two logs is equal to the product of the two pieces inside. So x times x plus 5 equals the log of 6. I keep saying log. You recognize that ln is the same as log base e. Okay, so we have this product. And now, since we have the log of something equal to the log of something else, the two things themselves must be equal. From here, we can just use algebra, standard algebra techniques, distribute the x. We get x squared plus 5x equals 6. We can bring the 6 over and factor that and use our standard equation solving techniques. We get x plus 6 times x minus 1. As the factors. That gives us negative 6 for x or positive 1 for x, but we have to remember that we can't use a negative 6 in this case because we're not allowed to take the log of a negative number. Okay, so that was 24. 25, we're given a log expression and we're asked to write it as a single log. So we're going to use the power property of logs to bring that 2 over as an exponent and the 3 and the 5. So we're going to get log a squared plus log h cubed minus log m to the 5. Okay, these parentheses tell us that we are to group these two pieces together. That's the log of a difference, and that's going to give us the log of a quotient by the quotient property. Now we have the sum of two logs, so we're going to use the product property to combine those two into our final answer, the log of a squared h cubed over m to the 5th. Okay, our last problem, 26, also a log problem. Here we're given a single log and we're asked to expand it or to write it as a sum or difference of logs. Okay, so here we go. We're going to take the log of the numerator, okay, and subtract the log of the denominator. That's the quotient property. Now we're going to see here that we have a product, so we can use the product property to split that factor, that product. We get log z plus log square root of x minus log y cubed. And now we're going to take care of all these powers. We remember that the square root is actually the 1/2 power, and the log of y cubed is 3 times the log of y. So there's our final answer. That completes problem number 26. So we're all done with this session. Thank you very much, and I wish you the best of luck on your exam. Bye now.